In most machine learning tutorials, you learn how to train models. But in real industry projects, training is only 10% of the job. The real challenge is deploying models reliably, serving them, versioning them, and making them accessible to applications. In this video, I'll show you exactly how to take a real HuggingFace model, wrap it inside a custom MLflow PyFunc model, register it in Databricks, and deploy it as a production-ready endpoint. Specifically, we will install PyTorch and transformers, download a real embedding model from HuggingFace, wrap it up inside a custom MLflow PyFunc model, implement load context and predict methods, register the model in MLflow Model Registry, and finally deploy it as a live serving endpoint in Databricks. By the end of this video, you will understand one of the most important real-world skills in modern ML engineering. That is, how to deploy transformer models using MLflow. Let us start with making a plan of what all things we need to do in order to serve the endpoint and create and deploy our model that we want to basically deploy on Databricks. So we'll be following these steps so that we have a clear guideline and guidelines as we are progressing. First one is going to be install PyTorch and transformer library. Now we are not going to do anything on our local platform. The only thing that we are doing locally is just create this project.1.txt file, nothing else. So I'll just go ahead and open Databricks, and I will just quickly log into Databricks platform using my Gmail account. And then after logging in, I'll create a new notebook and attach the serverless compute to it. I'll just go ahead and create a notebook, and I'll name this notebook as transformer model deployment. Transformer model deployment. Now, what do I mean by the statement that I want to install some packages? Locally, we have Python, but here on serverless, how do I install my packages? So first of all, let me connect it really quickly. And then from here, I can go to more and from here I can go to configuration. And inside the configuration, if you see, I have this added and installed. Now, the way you install a new package is you write the package name here, transformers, for example. Now, the reason it is giving me this is because, one second. So the reason it is giving me this is because it wants me to use equal to for specifying the exact version, but I don't need to do that. And then I also need to do PyTorch. Okay, sorry, Torch. So I want to install Torch library and then transformers. But let me see if I have already got these installed or not. Transformers, I don't have this package, or maybe let's say Torch. I don't have this either. So what I will do is I will install these two packages really quickly. So I'll go to edit, transformers, Torch, and I will apply. Now when I apply it, it would take some time to basically install these packages. So let's wait because it rebuilds the container and everything. So I'll just pause this video right here and I'll let it installed first and then we can resume it. Okay, so as you can see, it took 3 minutes to add these packages. Now let us quickly test whether we have these packages ready or not. So from transformers, I will quickly try to import a submodule called a function, a class called auto tokenizer. So if this succeeds, that means my package is working fine. I can also see quickly if my import torch is working or not. Since it is loading it, it most probably means our packages have been installed. Okay, It says auto tokenizer is not found from transformers. Why is that? One second. Let's see. From transformers auto tokenizer. Why it's not working? Did I spell it incorrectly or what? Auto tokenizer. Why it's not even okay? This time it worked somehow. I don't know why. Okay, so now I have imported the torch. Okay, so now our package imports have been completed. Let's go back. So we have been able to install this. We have been able to complete the first step. Now let us download the model from Hugging Face. Which model I am trying to download? So it's a embedding model provided as part of sentence transformers, and sentence transformer itself is built on top of transformers. So the exact model is paraphrase mini LM. The reason I took this model is because it's lightweight and yet powerful. So it's a powerful embedding model which we can use. So let me navigate quickly to Hugging Face platform. Hugging Face. Now from Hugging Face, I can search all sorts of models. I have already logged in. Although you don't need to log in and you don't need to get a Hugging Face token for this video. And the reason for that is because this model is openly available and it does not require the use of this token. So I'll just search for this model that I just showed, and that is paraphrase mini LM. So paraphrase mini LM. So this is the model that we want to basically use here. And since this is L3 version, so let's go for L3 only. So paraphrase mini, this one. So this is the model that we want to get. If I go inside the files and versions, I can see the model files. So you can see model.savetensor is the largest file and it's hardly 70 megabytes, which is good. Now I need to grab these models and I need to make them available somewhere here in my Databricks notebook. Now how can I do that? So what we can do is we can download them definitely, but where will those downloads go? That's the one concern that we might have. So what we can do is we can create a folder. Maybe let's create a folder which would hold our model. So model files. I'll create this folder for model files. So now let me refresh it. Okay, so I've got this model files. Now what I can do is I can download my models in this file. Now how am I going to download it? So the way to download it is by using it. So basically what I'll do is I'll quickly from transformers I will import auto model, and if I run this, it will import the auto model and auto tokenizer has been already imported. Now after this, what I want to do is I want to create two variables. First one is auto tokenizer, and it's already giving me suggestion of the command that I have to use. So it's called from pre-trained, and what will be the key? The key will be this exact key that we get from Hugging Face. So now I can provide this key here. So this will create my tokenizer, and similarly I can create a model. So auto model dot from pre-trained. Similarly I'll paste it, and if I run this, it will give us some warnings like you are not using HF token and things like that, and it will download it. But where exactly it is going to download? For that we need to basically create a variable called a model download directory, and it will point to this directory here. So I'll just try to copy this path. How can I copy this path? Yeah, so from here I can copy the path and I can paste it. You see workspace and model file. So this model files directory has been saved here. Now what I can do is I can do something like token dot save pre-trained, and I can do model download directory here. Similarly, I can do model dot save pre-trained and model download directory. So this would just take our model files and it will download, place these in here. Okay. And why are we downloading it? Because later we will be referencing it in our custom Python model that we will be creating. So if I run this, it should kick off the model download process. So we are seeing that it is basically downloading it. So yeah, so you see all these progress bars are showing that the download is in progress. So let's wait for it for a couple of seconds for it to complete. Meanwhile, let me see how I can, 1 second, let me see, let me close this first of all. Is it complete? Yeah, so it's complete. So if I refresh this now, so in download files, you see configs, model safe tensors, all these files are available now. Now I don't need to use these token and model variables. I can just use these one. Okay. So let's see how to use these now. So our next step is to basically learn to use these models that we just created. So what we will do is we will quickly take these TOK and model variables and we will try to see if we are able to use it on some text. So let's create some texts here. This is a sample text. Okay. So I'll just run this and then I will, so creating embeddings on top of the text using the models that we just downloaded is a two-step process. First we call the tokenizer on the text and we get inputs, and then we pass these inputs to produce the you can say to pass through these inputs to the neural network. So in the text I want to return tensors. So basically I want to tell it in which format I have to return the tensors. I'll say PyTorch, and then I would like to set the padding as true. Now, why do I need to set padding as true? The reason for that is when you will be using text of different lengths, you will need to align them, right? Because one text can be smaller, another can be larger. You need to add some extra fields, extra tokens to be able to basically give you the same length. So if I run the inputs now, so you see we got input IDs and it was a much quicker process. Now we take these inputs and we pass it to the torch. So with torch dot no gradient, so we run it in a context manager and we get outputs. In the outputs, what we get is we take our model. Where is our model defined? Our model has been defined here. Now if I take my model, I just need to pass my input, sorry, but here inputs is a dictionary, but rather I want to unpack it, so I'll just put a double star in it. So don't get scared from this double star, it's just unpacking it. So input IDs and token type IDs and attention mask, all these are unpacked. So if I run this, it will take some time, like little bit of time. So I get outputs. Now if I check my outputs, what will I get? I'll get a detailed output of all the hidden layers information, but I want to get only the last hidden state. So I can get last hidden state. I get a very long tensor. Now if I check the shape of this hidden tensor, you will see it has a shape of 1 7 384. What is that? So 1 corresponds to the batch. If let's say I add one more text here, one more text, and if I run through this again, and if I check the shape one more time, you will see now it will have 2, which means this dimension represents which text we are dealing with. And this 384, you can imagine 7 different arrays of length 384. Usually we mean it across this axis, so that what we get is we get a 2 by 384 matrix, where each of this dimension represents the text and 384 is the actual embedding. So I hope you understand, and this is how we use this model. Okay, so yeah, so now what we need to do is we need to move to the next steps, and next step would be to create a custom PyFunc model and log that model in MLflow. Okay, so the next thing is to implement a custom PyFunc model, and exactly in that we will be implementing a class which will have two methods. One is going to be load context and another is going to be predict method. So let's navigate back to uh, the transformer notebook that I had. I would like to import MLflow really quickly. Now I will create a class. So I'll create this class as maybe sbert and sbert custom model. And this sbert custom model is going to inherit from MLflow dot py function dot pyfunc model. So we need to python model. Okay, so we need to inherit from this, and we need to define two methods here. So I'll quickly define load context. This takes again itself, self means itself, and then context, and I'll just pass it for now. And then we will define a predict method. This predict method should take again self, it takes context as well, and it takes, I'll tell you how this context and all will be defined. It also takes model input. Okay, and it is expected, right? Now what do we do in load context? In the load context, what we do is we take the context that is passed. Now how can we pass it? I'll show you when we have to log the model. So while logging the model, we define the context, and while passing the context, we take the context and we load the model, whatever we have to do, right? Okay, so now what I can do is I can assume that this context has a you can say artifacts key. For now, just assume that it has the artifacts key, and from where we will see how to pass that artifacts. Okay, so what I'll do is I'll say context dot artifacts, and this will be a dictionary. Assume that it's a dictionary, and I'll tell you how you can assume that. So I'll say model directory. So this will give me the model directory, and the model, by model directory I mean this model files directory. Okay, so I'll say model dir, and then from this model dir, what I want to do is I want to run these two methods. That is, I'll just copy these two methods and I'll paste them here. So I want to run tokenizer and model. Now I don't want to pass this you can say this HuggingFace string. Rather, I want to pass my model directory here. So I'll just pass model dir here. Now after this toke and model has been defined, I need to also attach these to this instance of sbert. Okay, so I'll say model, self dot model is equal to model, self dot token is equal to token. Okay, so what is the next step? Next step is to implement the predict method. Now where will this predict will be coming from? And it depends on you. It depends on how you want the model input to be passed. Let's assume that it will be passed as a pd.data frame. Now for that we would need to define pd. So let's define pd here. So import pandas as pd. So we are forcing it. You could have just accepted a list. Okay, so that is up to you. Now what we want to do is we also want to return a pd. So we want to return a data frame with a key called predictions. and this prediction will be having some, let's say, embeddings. Now we will be creating these embeddings. For now, just for now, I'm creating the I'm setting up the inputs and output context of this predict method. Now for this model input, I'll assume that it has a text field. Okay, so this predict has a text field that we want to reference. So what I'll do is I'll do something like model input. I'll grab the text and I'll convert it into a list. And why I'm converting it into a list? You see, when I tested this model, I had a list, right? So that is the rationale. So I'm telling you my rationale of why I'm basically writing out certain line of code. So I'll just say texts. Give me a minute, 1 second. Okay, so now that we have the text ready, what we have to see, what we have to do, we have to do the exact same thing that we did here. So I'll just grab my input here, input from here, and then I'll grab my with dot torch dot no grad. Okay, so I will get my outputs, and after outputs I get my hidden state. And if you recall, this hidden state was giving me a entry which is of the shape. So I have to mean it. So I have to mean it across one axis. So I'll just try to mean it across first axis and see what happens. So you see, I have meaned it, and now I'm only getting entries like this. Okay, so now what I can do is I can just take this and return this as it is. So I'll just take my last hidden state and get the mean, get the axis along the axis 1, and I'll name this as embedding. Okay, and this embedding I'm returning as the prediction. So this is my custom Asbert model. Now what do I need to do next? Let's see. We implement this model, and the next thing that we need to do is we need to take this and register it in the so first of all, we need to log it before registering it. We will be looking at that next. Okay, so for that, let us now move to the notebook and let's see how are we going to register it. Now, not register, but before that, we need to log the model. Now, to log it, anything that has to be logged using MLflow, it has to be associated with a run, and run has to be associated with a experiment. So what we will do is, first of all, we'll create the experiment here really quickly. So for that, let us first of all check our path, because experimentation looks different than what we do locally. So I'll just get my current working directory. So I've got this. Now what I need to do is I need to set my experiment. So I'll do set experiment, and under that I can do something like, sorry, I can grab this also, or if you wanted to be fancy, then you could have just appended it. So I'll just name this experiment as logging Asbert model. Okay, so I'll just run this. Now this will create the experiment. So it says it is creating it. Okay, now after that we can create a run context. So with MLflow.start run, within this run I will be logging the model. So you see, all this code is already being provided. So what I'll do is I'll just run MLflow.log model. Now this model, we need to provide 4 pieces of information. First is artifact path. Artifact path, it will be a certain thing. We will fill out these details, but let us first of all see what all we need to pass here. We need to pass Python model argument. For now I'm just putting this as a string, but let's wait. Python model, after that I need to pass the actual artifacts. Okay, I'll see what has to be filled here, and then we can pass input example as well. See, all input example is not required, but it will make your auto generation. So basically what but what Databricks does is it auto generates the scoring script. So if you want that to succeed correctly, You can provide input examples also. Now, what is the artifact path? It can be anything. You can provide anything, any string that you want. I'll show you what exactly this does once the model is logged. Then Python model. Python model will be the actual class instantiated. So I'll just take my SBERT model and I'll call it. Then in the artifact, it will be the dictionary which is we are fetching here. So context.artifact. So I need to provide a model directory here. Model directory. So what will be my model directory? So I'll just grab the path here from here. So this will be my model directory. What will be the input examples? We saw that in input examples, we are expecting the text to be there, right? So I will create a data frame with a key called input example with a key called text. Okay, so sorry for the disturbance. So what I was saying is in the input example, we have to pass in the same format in which we are consuming it. So we need to have a text field and we can provide maybe a list. This is input example. Okay. So now it should log the model. Okay. So let's log it and I'll show you what this artifact path means. So I'll just run this, but this time it is going to take some time. Why? Because when I call this expert, it will run all these steps. Okay. So it is going to take some time. Let's wait for it and let's see how much time it takes. So it says it has no attribute called log model. Why is that? MLflow dot okay, sorry. I think I need to pass the PyFunction model. So it's not a normal model, but rather PyFunction model. So let's wait for some time and let's see how much time it takes. So it's loading. It's still doing its job. And you see loading waits. How it is loading waits? Because we have called these two methods and it is looking at this model directory and it is loading these things in here. Okay, so let's see. Yeah, so it's completed. Now let us open this run and I'll show you certain things. So when I open this run and if I navigate to artifacts, you see this model name. That is what is being referred here, artifact path. Let's say I register, I log one more model as model 2. And if I run this again, this will come out as model 2. So let's wait for it to complete. Okay, so now if I open this experiment, this is going, not this experiment, but this run, this will be model 2. And this model has all the things like artifacts, model files and things like that. Okay. All right. So I think something in place of model files, if I do this, let's see if this solves the issue. Because currently the files are coming, this directory is also included somehow. I don't know why. We should not have this directory here. Okay, let's open the run. Why it is including the directory? That's a good point. 1 second. Artifact. Yeah, this time it's not including the directory. So that is why I was concerned. Okay, so there are some warnings. Failed to run predict on input example. Dependencies introduced in are not captured. It's saying, okay, so what exactly are we getting here? Okay, so somehow, okay, so what is happening? We pass this and so what? Failed to run predict on input example. Okay, so it is basically taking the input example and it is trying to run this. Okay, but why it is failing? Can't we call? Let me do one thing. So let's take this and let's call text here on this data frame. Yes, it's working. And let's say if we call toList and see if it's working. So why is it failing then? So we are able to load the list, and then okay, fail to validate serving input example data. Okay, let me see. Let me debug this. Give me a sec. So I saw one issue which could could have produced this, because we are directly calling this tokenizer. We are not calling the self dot tokenizer, self dot model. Let's run this again and let's see if this solves the issue or not. Okay, so let's set the experiment, and then after that let's run this again. This time I think that was the issue, but let's see. Let's wait for maybe 20 seconds again and see if we are able to log the model correctly. It's still not working. Fail to validate serving input examples. Why it is failing here? Okay, so the issue was not how we were passing the data, but rather how we were returning the data. So earlier, if you recall, I was using this as the return value, which is basically a PyTorch value, and it is the MLflow was not able to understand it properly. So now what I did was I just looped through it and I created this list of embedding values. So now we'll be getting this clean embedding list, and now we are able to run this log model method. After the log model method, we have to basically, next step is to register this model. Registering is different thing. Logging is associated with a run, and registration is associated with the model catalog. And model catalog works differently in the what you can say, in the Databricks. So you have got this workspace, and inside this workspace, so workspace is the catalog name, default is the schema name, and inside this default you have to basically provide your model name. So I'll just define the model name here really quickly. Let me also yeah, so I'll say workspace is the catalog name, dot default is the schema name, and this SBERT model new one. Okay, new one is my model name, and then I will have to also get my logged model URI, and it follows the method like runs and then ID of the run, and then finally the model. So let's grab this from the run itself. So I'll just open this run which logged the model, and from here I can get the artifact, and you will see here model URI here. Okay, so I can just grab the model URI from here, and then put it here. Okay, and then after that I can register my model. To register it, I can call MLflow dot register model. So MLflow dot register model, and I can pass the logged model URI and the model name. So let's run this. So let us wait for it to complete. So successfully registered model. Now we should be able to see the model. So now you will have a versioned model in the workspace. So if I open this, if I open the default, you will get SBERT model new one. So this is our model. Okay, you can have multiple versions within the same name. Now finally we can serve the model. How are we going to serve? Serving is quite easy, because all the hard work was in understanding the input output format, creating a custom PyFunc model. This is where the real work was. Serving is quite simple. Okay, one second. So what we need to do is, okay, let me go back to that page again. So I'll just come here to the catalog. I'll open the workspace. I can open the schema. I can open the SBERT model new one, and for this new one I can click on this this model, and the only detail that I need to provide here is sbert new model, or whatever you wish to have it named. So you will get this URL. That URL is something that you can use for calling it. So if I go ahead and create this right now, it will take forever. It takes about 30 minutes to spin up. Last time it took 30 minutes. So that is why what I'll do is I'll go to serving, and I'll use the already created one that I have. So it has the same configuration and all. I'll just use it, and I'll showcase you how you can basically work with it. So now that we have done all the hard work of creating these endpoints and all, you would want to use it and consume it, right? So what we can do is, once your endpoint is ready, its status will go from updating to ready. And if you click on it, you will be able to see all the details about the endpoint, like what is the URL and what is going to be the configuration of the endpoint. And besides those details, you will be able to see the latency, request per second, response rate, GPU or CPU usage, whatever you are using, memory usage. So all the monitoring and observability you are getting for free. Now, how do we consume this model? Okay, so to be able to consume it, you would need to first of all come here and open the settings tab. Under the settings, you would want to grab the Databricks token. So I'll go inside the developer, and I'll navigate to this access token. I'll click on manage, and I'll generate a new token. I'll name this as testing, and I'll put the lifetime as 1 days. Let's generate it, and let's grab this token. Okay, let's go to the Databricks, and let's create a new testing notebook. 1 second. I'll just open a new tab, maybe new notebook, and in the notebook I'll paste this token. So I'll name this token as HF token, and I would just make it as a string. Now I will come back to my endpoint. I'll go here and use, and under the use I'll go to Python, and I'll grab this code. Now under this, I see this option for Databricks token. I'll just remove this, and I can not HF token, sorry, because we are dealing with HuggingFace, so I thought it's HF token. So I'll call this as Databricks token, and I'll paste it right here. Now you see all of these have been auto generated, and the reason for that is because we provided all the context of what will be the input data, what will be the output data in our custom PyFunc model. So this is why Databricks is able to generate all these details. We did not have to provide the scoring script as well. So I'll just first of all attach the serverless compute to this notebook. It's ready. If I run this, it's now ready. Now what I can do is I can score my model. Okay. Now in the scoring, I want to provide the input example. Now input example will be a data frame. So I'll just create an input example really quickly. pd.dataframe, and I would like to pass a text, and this text would be, this is a test maybe. Now if I run this, it says, okay, so I think input example we need to pass. If I run this now, it will hit the SBERT embedding serving. Now it might take some time because the model, the endpoint that I have been using here was a older one, and it will basically spin up the servers to start the process, and then only it will be able to make the scoring. So it will take some time, some maybe 1 or 2 minutes as well, for this to warm up the instance again, because our concurrency is set to 0 to 4. So because of not using the instance for some time, it has been switched off, and now the instance is being like wake up, in the wake up mode. Currently it's not it has not completely woken up, otherwise we would have got the response. So it is taking some time. Let's wait, and let me pause this video and let me resume it back once this is done. So as you can see now, the results have been obtained. But now that our instances have been warm, if I score the model once again, it will be almost immediately. So you see, it returned the results within seconds. Now, there are some not so recommended ways to keep these instances always warm. Maybe by setting up a server and running a cron job which periodically sends requests to this endpoint, and it keeps the instances warm. Or if you have a use case where the activity is very high traffic activity going on throughout the day, then in that cases these instances will be always warm. But even in those scenarios, it's not recommended to basically go for zero scale down. We usually have to have at least some instances always warm, so that we can cater to the request that can come at uneven times. With that said, I think this is what I wanted to basically discuss in this video, in this project, that how do we build such a kind of serving system. Okay, so that's it. You have successfully taken a HuggingFace model, wrapped it inside a custom PyFunc model, registered it in Databricks, and deployed it as a production endpoint. This is the exact workflow used in machine learning systems to deploy models reliably and at scale. So if you found this video useful, consider subscribing to the channel. I regularly post real-world ML engineering tutorials like this. Thank you for watching, and I'll see you in the next video.